So I got to go to Burning Man this year. Yes, that Burning Man. The Burning Man, also known as Muddy Man. But before the rain fell, I was there with an amazing group of people whose mission it was to capture the art on Playa and preserve it for the future in virtual reality. We even got these cool official media crew badges that entitled us to, well, absolutely nothing, because that's Burning Man humor. I learned a lot in this process, especially about Gaussian Splats, and I thought it would be cool to do a video showing the process I went through to convert raw footage on Playa to models for use in VR and in the future. The art piece I chose in particular is called Farmer of the Rigger, and it's based out of LA. I'll include a link to this art piece below. I chose it for a number of reasons, the first of which is its size. This is a very large art piece. It stands about 18 foot tall and about 16 foot wide. So it was a challenge to capture. The other reason I chose it is honestly because we kind of screwed up that day. When we showed up to this art piece, we had a 360 camera that we used for doing just regular environmental capture, but we forgot the DSLR. So we don't have a bunch of loose photos that we normally would have for doing photogrammetry. What we did have is me walking around this art piece with an 8K camera. And actually, the footage that you're seeing here is 8K resolution footage, but it was just shot on a Galaxy S22 Ultra and in portrait mode. So I put it in 8K, and I did 2 loops around the art piece. The first loop was about eye height, and the second loop was about knee height. I was, of course, very diligent to make sure I kept everything centered as I walked around the art piece. In the end, you'll notice that we missed some very important data with this video. Most notably, we didn't get high enough. Even at eye level, there are parts of this model that are simply not going to be seen. Of course, nobody is really tall enough to see the top of this model if we present it at real scale. But even some parts of the model weren't scanned correctly, like the tops of the wrists or the hands and the knuckles on the ground. So the first piece of software that I wanted to try for reproducing this art piece was actually Luma. Luma's done some amazing work this year on making neural radiance fields very easy to use, and they also have the ability to export 3D models from their NeRFs. So it's super easy to create an account and sign in, and then once you've got your account created, you just go into My Captures and go into Create. Luckily, Luma takes video files directly, so I was able to simply upload that raw 8K footage to Luma and get a reconstruction. Super easy. When it's done, well, this is what we got. Now, this looks very impressive right off the bat. And it is. I mean, for the simplicity of just uploading a video and getting this, it's incredible. But there are a number of things that I think are just maybe slightly misleading about this video. This video is a preview of their own neural renderer that they have in the cloud. And so the first thing that I am going to do is try to figure out what kind of model we can get out of this for use in VR. And if you click the cube button down at the bottom here, and let me hide the background, or actually let me get close to the model. Now what we're looking at is we're looking at a web-optimized version of their renderer. This is not a NeRF renderer. This is a 3D model renderer. And you can already see some of the challenges that we start to have the moment that we try to get from a NeRF, a neural radiance field, into a traditional 3D model. There are a lot of struggles with details like chains, and, you know, of course, no fault of their own, but we didn't provide them with all of the detail. We're missing parts of the model back here. But you know what? This is a web view and not a true 3D mesh, so my next step was to see what I could get out of this if I download it as a GLTF. So downloading that as a GLTF is as simple as clicking the download button and grabbing that. And then I like to use this GLTF sample viewer that's available online and free. And you can just drag your GLTF model into it. What's kind of nice about this environment is you can add different environmental images and see what your model is going to look like in different environments, different lighting conditions. So I like to switch over to this wide street because it has a very bright light in the background. In fact, if I turn off the blur, you can kind of see where the light source is, and you can even change the direction of the light source. So if we go from negative Z to positive Z, you can see what we get out of this model. So yeah, I mean, this isn't the most natural light source for this model, but you can really start to see some of the challenges that come from kind of doing a NeRF-based volumetric to 3D model approach. This texturing obviously wasn't on the original art piece, but this is a pretty darn good reconstruction. Biggest problems that we have are in these spaces back here that we just didn't capture the data. Again, we're missing a lot of detail about the hands. We've got holes down here in the this is where they had natural gas, I believe, or propane rather, for the burn barrels. And there's just a lot of problems with the chains here. Again, I don't want to fault Luma for what they've produced here with the kind of limited data that we gave them, but any of these details, any fine-grained details like chains and thin metal pieces are always going to be very, very difficult to reproduce in any kind of photogrammetry pipeline. So the next thing I wanted to try is, rather than starting from a NeRF and going to a 3D model, what if we were to use a more traditional photogrammetry pipeline? And for that, we have used reality capture. So reality capture allows you to take in a bunch of photos. And reality capture does have the ability for us to import a video directly. But I found when I was importing the 8K video that reality capture really struggled with the import. It was taking a really long time for it to get individual frames, extract those frames. So I decided to help it along, and I used a command line. Specifically, I used the tool FFM Peg, and this post on Stack Exchange was helpful. Basically what you do is you just call FFM Peg -I for the video file that you're giving, and then how often you want it to take a frame from the video and output it. So in this case, -R followed by a 1 would mean to export a PNG file every 1 second of video, or 0.25 would mean to export a frame every 4 seconds of video, 0.1 every 10 seconds, and so on and so forth. So I specifically did -R1 so that I could get a frame for every 1 second of video, and then I imported that into reality capture. And you can see I still got a lot of cameras here. Plenty of frames, pretty good coverage, but again, the problem is that there wasn't a lot of difference in the height. We had up high, down low. There's a little more difference in height than you can see here, because remember, this model is 18 feet tall. But still, we didn't get high enough to get the coverage that we needed. The model that was produced by reality capture is pretty good. If I look at the back, it did its best to fill in those holes, and it did a pretty good job of filling in those holes on the propane tank as well as on the top of the hands. But clearly it still very much struggled with the chains. Those are completely missing. The top of the jaw is missing here. And really the biggest problem for us was the top of the hands. Wasn't able to reconstruct this. There were also a number of holes that I was surprised to see show up. For example, there's a hole here above the nose and in the eye. So we could certainly fix these. It's not terrible. Also another one up there. It's not terrible to open this up in a tool like Mesh Mixer and delete those holes and have Mesh Mixer kind of average the texture across them. But it would have been a lot of work to do this. And again, if we had been there with the right equipment and cameras, taken a lot more photos, different elevations, and really done a good job of getting source footage, then this tool would have been able to do a better export. But that's kind of not really the point of what I'm wanting to show today. I'm wanting to show how far advanced Gaussian splats are with the same or even less input data. So this is kind of right now the end of what we can do as far as virtual reality is concerned, because once we go into native neural radiance field rendering or native Gaussian splat rendering, there's not really a good way of doing it in virtual reality today. NeRFs are way too slow, and Gaussian splats just don't have the native VR renderers yet. But I'll talk more about that in a minute. Still, I know this is the path that they're heading, so I wanted to circle back to Luma and give them another chance. This time, if I just kind of assume that we don't have to end up with a traditional 3D model, I wanted to see how far we could push it by viewing the radiance field directly in an engine like Unreal. So Luma supports Unreal Engine. They have a plugin for it that allows you to see your light field directly. And so this is where you download the light field. I'm not going to walk you through getting the plugin set up for Unreal Engine, but that's documented here, and it's very easy to do. Once you have it set up, you go into Unreal Engine, and basically you just drag and drop your light field into your project. And then you're given a number of options. You're given the option for baked lighting or dynamic lighting, and whether you want the entire environment or just the subject. Really quick here, what is super impressive about dynamic lighting is that this plugin allows your scene to be relit. So we could easily take this model and make it appear to be nighttime instead of daytime. There's some other great videos online that show that, so I'm not going to walk through that here, but it's incredibly powerful. What I wanted, my goal was to recreate the experience of being on Playa at this art piece as much as possible, so I'm going to move forward with the baked lighting. But just know that there's some really impressive capabilities here for being able to relight the scene as if it was captured at a different time of day, different time of year, different lighting conditions. So now here we are in Unreal Engine, and let me close this drawer, and you can start to see really the power of having the light field, the NeRF itself in its native capability, because we're starting to see a lot more details that were missing before. Now we can see the chain that was missing here. We can start to see that the bottom of the jaw is more filled in. There are no holes in this. We've got some detail on the hands back here, the chains. But I do want to point out that this frame rate is not high. I have the render quality set to high because I want to give the NeRF the best chance possible to look good. But even when I set the render quality to low, though the frame rate jumps up, frame rate still isn't really good frame rates for virtual reality. And look at what happens to the quality. We have lost all of the details with the chains, and really we just have so much noise in the picture here. It really becomes pretty much unusable. So now I want to switch, of course, to the topic that everyone's here for, which is Gaussian splats. These are a very different way of rendering. We still start with point clouds, But rather than rendering those point clouds as kind of volumetric fog, we render each of those points as a gradient on the screen. And it's stacking those gradients on top of each other that give you the actual blending that is necessary for realistic looking light, reflections, translucency, and all those effects that really make a scene appear photorealistic. Now, it's important to realize that Gaussian Splats are very much in the research phase right now. And so you're not going to go to the GitHub repo and find a setup.exe that's going to put this on your machine ready to go. You are going to need to go through the process of downloading code and building it before you have something you can actually run. Now, I'm not going to walk you through all the steps necessary to get these tools on your machine, but there's a YouTuber who goes by the name the NeRF Guru, and he's put together a step-by-step video that will help you get it running on your machine. I'll go ahead and provide a link to that video below. Now, training a Gaussian splat is like training a NeRF, which means that you're going to start with images. So if you're starting with a video like I was, you'll need to use the FFM Peg trick earlier to export out those frames. Now when I did that, of course, I ended up with 8K portrait frames with 4,000 something resolution by 7,000. But when it was time to bring these frames into the training model for Gaussian Splats, it really didn't want anything over 1.6K images. So I started with the original frames, but then I ended up having to downsample them. And I ended up downsampling them to images that were pretty much very close to the 1.6K size. And those are the images that I ended up training on. Now, once your model's trained and you're ready to view them, you're going to drop down to the command prompt and run this executable. And this first parameter here is the resolution that you want the renderer to run at. So you can have the renderer run at a lower resolution than what your graphics card is capable of. And that way you can get a little bit more performance out of it. The second parameter here, the iteration parameter, is basically, you can think of this as the quality of the model. So when it comes time to train the data, you specify how many iterations you want it to train. And I knew that my graphics card, which is a 3080, didn't have the total amount of memory that was recommended for training. They recommend something like 25 gigs of VRAM, but my 1080 only has 10 gigs of VRAM. So they recommended that you only train for 7,000 iterations. But there is a neat trick where you can force it to train on the CPU rather than GPU, and then even have it timestamp, or I guess do checkpoints as it's training. So in this case, I had it do a checkpoint at 7,000 iterations, 10,000, 15,000, etc., so that if it ran out of VRAM and crashed, I would still have a previous quality checkpoint that I could use to go ahead and visualize. So that's what the 30,000 parameter is here, which iteration to load, and 30,000 is kind of the maximum that they recommend you train to. Since I was training on the CPU, it made it all the way through, and I'm able to load that model. And the first time I loaded it, I was shocked. I honestly thought something was wrong, because when it first opened up, I thought I was just looking at one of the frames from my video. But then I grabbed the keyboard and I started to move around. Now, I should mention here that due to the screen capture software running, this is limited to 60 FPS, but without it, this is easily over 120 FPS. And I can't even begin to tell you the night and day difference. I mean, you can see it for yourself, but just look at the detail captured on the hands from areas that were occluded or not even reconstructed properly with the other tools. There's noise there, but it's very clear what we're looking at. the propane tank and the valve there. The fact that there's no holes on the top of the propane tank. And of course the top of the wrists. Again, we didn't have the best angle possible when we had the original capture footage, but it did a good job filling it in. The detail on these chains is just incredible. Unbelievable detail compared to before. And the metal work too. The metal pipes. The top of his jaw is completely filled in. There are no gaps. And even if we come down here on the ground, seeing the metal work down there, it's just clear as day. I was even happy to see how well it reconstructed his nostrils. And this was the first time that I noticed what I think are lights up there. I actually never saw this piece at night, unfortunately, but I'm assuming those are colored lights. The detail that it captured in the eyes, the kind of stained glass work, is just incredible. And then there's the details about the environment that it captured. The barrels. Not only did it capture the symbols on the sides of the barrels, but also these little LED lights that were out on the ground, lighting up the barrels at night. There's a barrel over here that only showed in a few frames, but if we come over here and take a look at it, we can see the artwork that was on the side of that barrel very well. And not only that, it kind of captured us and our bikes off on the side, all from those 2 loops of video. And don't forget that this is downsampled, right? Like, this isn't the 8K frames anymore. This is now effectively 2K frames. So look at the amazing reconstruction that it did from even lower resolution video. Now, of course, I don't know what Luma does on the inside. When you give it an 8K video, they may downsample it to 2K as well. But just the reconstruction work here was really, really unbelievable to me. So where does this leave us? Well, don't forget that Gaussian Splats are a brand new research technology. They don't have any runtime support today. The only true runtime support from any company is the support from Luma AI integrated in Unreal. And in fact, during the production of this video, Luma added support for web-based Gaussian Splats. So this space is evolving incredibly rapidly. And of course, something conspicuously missing from this whole presentation is Unity. A lot of VR applications today are built in Unity, and we don't have support for Luma or Gaussian Splats, at least in any open source format. There are some open source projects, or at least projects listed on GitHub, where they've promised to provide source, but we're still a little ways away. So I think ultimately this technology, Gaussian Splats, are going to provide us with the opportunity to have the most realistic recreation of a scene possible, but we're still probably a couple months away, at least, from being able to experience it. Anyway, I think that's everything that I wanted to share. I am super excited about this technology, and if you're excited about it too, please reach out to me. You can find me on LinkedIn or at my website, which I will also link in the description below. Thanks for watching.